Hi students, very good morning. Welcome to Govidya. Okay, I think very few people are joined. Join the other students also. Okay, it's okay, no problem. We'll start the session. In previous session, we discussed for a capacitor motor. Okay, if in that one set is giving torque 1, other is giving torque 2, we need to compare which torque is more or which torque is lesser. Okay, let's see the circuit connection 1. Let's take it as 1. Let's take this is connection 1, this is 1 and this is 2. Okay, if you see the circuit connection 1, let's draw the equivalent circuit. If we apply voltage V, here also I current will flow, here also I current will flow. This number of turns divided 2 times, n by 2 and n by 2. Since the voltage here is V and current will flow is I, here also V, that's why I current will flow. Okay, let's calculate the ampere turns. Ampere turns is nothing but mmf. How much will come? I into n by 2 plus I into n by 2. Total ampere turns will be In. Okay, let's see the second circuit. If you see the second circuit, it is connected, main winding is divided into 2 parts and connected in series. So now what will happen? This is the applied voltage V. Here voltage will be V by 2, here voltage will be V by 2. Since V by 2, the current also here flowing will be I by 2 and here I by 2. This will be n by 2, this will be n by 2. Therefore, ampere turns in the second circuit will be I by 2 into n by 2 plus I by 2 into n by 2. It will come around In by 2. Okay, we know that torque is directly proportional to V by F, that is directly proportional to mmf. Okay, in the T1 mmf is equal to In, T2 IMF is equal to In by 2. Okay, so if you see the relation between T1 and T2, T1 will be greater than T2. Okay, the option is C. Okay, option is C. Is it clear? Good morning, Prabha. Okay, let's move on to the next question. A 6-pole 50 Hz 3-phase induction motor is running at 950 rpm and has rotor copper loss of 5 kW. Its rotor input is, okay, let's see the concept behind the question. The concept is about, relation between copper losses to rotor input. What is the formula we know? That means relation rotor input is to rotor copper losses is to gross mechanical power developed is can be written as 1 is to S is to 1 minus S. Okay, so they are asking rotor input power. Okay, let's take the ratio. Rotor input power to rotor copper losses is going to be 1 by S. Therefore, rotor input can be written as 1 by S into rotor copper losses. Okay, so for that in the given data, if you observe, what is the given data? The given data is poles, 6 poles given, frequency 50 Hz given, speed NR is 950 rpm. Copper losses are given as 5 kilowatt. Okay. For calculating this rotor input, we need slip. Okay. For calculating slip, what is the formula? Slip is equal to ns minus nr by ns. So we need to calculate ns first. What is ns? Ns is 120 f by p. How much it will come? 120 into frequency is 50 Hz, poles are 6, it will come around 1000. Okay, let's take it as equation 1. Now slip will be 1000 minus 950 divided by 1000. It will come around 50 by 1000. Okay. Therefore, from equation 1, rotor input power can be given as, they given 1 by s, no? So it will be 1000 by 50 into 5 kilowatt they given, you can write it as 5000. This will be 100. Therefore, rotor input power will be 100 kilowatt. Rotor input power will be 100 kilowatt. Is it clear? Okay. The option will be A. Option will be A. Okay. So in this question multiple concepts are included. Okay, so if you know the basic relations, then you can solve the question easily. So don't get confused by seeing the question. Let's note down the given data clearly, and based on the given data come to the conclusion for relation or formula. Okay, whatever you know. So based on that, by substituting given data, we can solve the question easily. Okay, let's move on to the next question. The question is about, in the shaded pole squirrel cage induction motor, the flux in the shaded part always. Okay, what they are telling, let's take like this. In one part of pole there is going to be copper bonds. Okay, in shaded pole motor, one part of the pole is going to be covered with the copper bonds. Okay, because of that, what will happen here, whatever the flux is generated, the flux is induces EMF E, and it will generate the circulating current I's in the copper bonds. Okay, generate circulator current I in the copper bond. Okay, so as per Lenz's law we might have studied, effect oppose the cause. What is the effect? Effect is the current. Effect is current. It will opposes the cause. What is the cause? Cause is flux. By Lenz's law, effect opposes the cause. Here effect is production of circulating currents in the copper bands. Cause is flux. Okay, so it will oppose the flux. That's why in shaded portion flux will be lagging. Compared to the unshaded portion. Okay, the flux in the shaded portion will be lagging compared to the unshaded portion. That will be B. Option will be B. Okay, let's move on to the next question. The question is given as, with V by F ratio keeping constant, if the frequency is decreased below the base value and the voltage is decreased proportionally, is fed to an induction motor, its starting torque and the peak torque for a variable frequency and voltage will be. Okay, so what they are asking is, by reading the question we came to conclusion that V by F control. Here both voltage and frequency are varying. Okay, this is the question concept in the question. So what they are asking, what about the starting torque and what about the maximum torque, they are asking. Okay, let's note down the equation. Let's note down the equation. Electromagnetic torque developed in induction machine can be given as 180 by 2 pi ns into S E2 square R2 by R2 square S X2 whole square. At the time of starting, what will happen? S equal to 1 at the time of starting. Then T start equal to 180 by 2 pi ns E2 square R2 by R2 square plus Sx2 whole square. So we know that ns is inversely proportional to f. That means since ns is given by 120 f by p, 120 f by p means speed is directly proportional to the frequency. And x2, inductive reactance. Inductive reactions x2 is directly proportional to omega L. That means x2 is also directly proportional to frequency. This then starting torque can be written as E2 square divided by F square into 1 by F. Okay, so this can be written as V by F whole square into 1 by F, since E2 is directly proportional to the supply voltage V. Okay, now as V by F is constant, the starting torque is inversely proportional to the 1 by F. This is the starting torque relation with respect to frequency. Let's see about maximum torque. Maximum torque is 180 by 2 pi ns E2 square divided by 2x2. Maximum torque is E2 square divided by 2 pi ns into 2x2. Okay, so from this we can write as maximum torque can be V by F whole square. Okay, so maximum torque is going to be constant. Okay, is it clear? So as in the question they told, it is a V by F speed control method, and the frequency and voltage are varying such that V by F is going to be constant. Okay, so we know the torque equations, starting torque equation and maximum torque equation, and we derived the relation between the torque to frequency. Thereby we come to conclusion that starting torque is inversely proportional to the frequency. If frequency is decreases, starting torque going to be increased, whereas maximum torque is constant. Let's see the options. What is the suitable option for us? Okay, starting torque will get increased, peak torque or maximum torque going to be constant. So our option will be B. Okay, let's move on to the next question. The question is given as a 3-phase induction motor running at 1440 rpm on rated supply will run at the following rpm when fuse of one phase gets burnt. Okay, what they are telling, initially motor we given the 3-phase supply, it is running at 1440 rpm. Okay, but because of one fuse got blown out, that only we are giving 2-phase supply to the motor. At what speed it is rotating? Since the motor is at running condition, it will start running at say nearby speed. That means if you see the first condition, If we give the 3-phase supply, the motor will start rotating, no? So when one of phase will burn out, and that means one phase supply is not there, then what will happen? Still the motor will start in running condition only, but less than the previous speed. That means the N2 will be less than the previous speed N1. This is the first condition. Second condition, to balance the power, that means to balance the power, this IR and IY will be high. IR and IY will be high compared to the first condition. Okay, so let's see the given options. Okay, what are the nearby option? Option is B, 1380. That means if one phase got out, that condition is called single phasing. In single phasing, motor still runs but at a lesser speed compared to the previous condition. So since it is running at lesser speed, the nearby option is 1380. So if they ask about currents, in the same question, if they ask about currents, current will be high in the second condition. Okay, let's move on to the next question. Dispersion coefficient is the ratio of, okay, dispersion coefficient is the ratio of. Actually, what is dispersion coefficient? Dispersion coefficient is not, is used to measure the leakage flux. How much leakage flux is going to happen in the machine, or if you see, it will be applicable for both transformer and induction machines. Okay, so it is the ratio of sigma is the ratio of magnetizing current to short circuit current. Okay, dispersion factor sigma is the ratio of I mu by ISC. What it will do? It is used to measure the leakage flux. This factor is indicating the leakage flux. Okay, so our option will be C. Option will be C. In the circle diagram for a 3-phase induction motor, the diameter of the circle is determined by, okay, the diameter of the circle is determined by. This is a direct theory question. In our circle diagram, you might have studied that. Whatever the diameter of the circle is indicating, rotor current referred to the stator. In your theory question, you might have studied. Okay, in theory concepts, I am not going into that. Okay, from the diagram directly you can get this. Okay, let's move on to the next question. Thrust developed by a linear induction motor depends on. Okay, thrust is nothing but the torque developed by the rotor circuit. It can be given as rotor input by speed. Okay, thrust F is given as rotor input by speed. It depends on both rotor input and synchronous speed. Okay, it depends on both rotor input to synchronous speed. Our option will be C. Thrust is nothing but the torque developed by the rotor circuit. Let's move on to the next question. The question is about crawling. Okay, they are asking about crawling. What the crawling in an induction motor is caused by. This question already we discussed. Crawling is nothing but the state of induction machine is running at 1/7 times of synchronous speed. Okay, when the induction motor speed is ns/7 and stable operation, and it running at stable operation, then that condition is called crawling. The main reason for crawling is harmonics. What are specifically 7th space harmonics? The reason for crawling is 7th harmonics, that too space harmonics. This we already discussed. Let's move on to the next question. The question is given as a delta connected 400 volt 50 Hz 3-phase induction motor when started direct online takes a starting current of 30 amps. When the motor is started through star delta starter, the starting current will be. Okay, in previous session we already derived the relation I star to I delta will be 1/3. Therefore, current when it is star condition will be I delta by 3. The given data I delta is 30. Okay, it will come around 10 amps. I star is 10 amps. Option is B. Yes, Prabha, it's correct. Option is B. So this relation we already derived in the previous sessions. You can refer that. Let's move on to the next question. The question is given as the speed of 3-phase induction motor is controlled by variable voltage, variable frequency, keeping V by F constant. This is important. Let's see the term V by F is constant. As the frequency is reduced, the slip at maximum torque will be. Okay, slip at maximum torque will be. We know that slip at maximum torque SM is given as R2 by X2. Okay, R2 by X2. Therefore, SM is inversely proportional to the X2. We know that reactive reactance is directly proportional to the omega L, or you can write it as just 2 pi F into L. So X2 is directly proportional to frequency. Therefore, SM is inversely proportional to the frequency. Okay, what they are telling, as the frequency is reduced, if frequency is reduced, slip at maximum torque is going to be increased. The option is B. Okay, option is B. Is it clear? So just I taken the relation of maximum torque, slip at maximum torque, that is given as R2 by X2. From there I taken the relation between slip to frequency. Okay, from there I derived the answer. Is it clear? Okay, let's move on to the next question. In an induction motor, if the flux density is reduced, what is that telling? Flux density is reduced to 1/2 of the normal value, then the torque will be. Okay, they are asking the relation between the flux density to the torque. Okay, we know that flux density Bm is directly proportional to V by F. So we know the torque equation can be given as 180 by 2 pi ns into S E2 square R2 divided by R2 square plus SX2 whole square. Okay, from this, in previous question also we solved, it will come around the relation as V by F whole square directly proportional to V by F whole square into 1 by F. Okay, so we may take torque is directly proportional to V by F whole square. So if what they are telling, flux density is reduced to 1/2, that means Bm, that can be written as Bm square. Okay, so T2 by T1 can be written as Bm2 by Bm1. Okay, from that T2 equal to, what is Bm2 reduced to 1/2. That means 1/2 whole square into T1. Therefore, T2 equal to T1 by 4. T1 by 4 reduced to. So our option will be B. So in an induction motor, if the flux density is reduced to 1/2 of its normal value, then the torque will be. So the question is simple only, but they are asking indirectly. Okay, we need to understand that. Okay, so we derived the relation between the flux density to the torque. From there we calculated the torque. Okay, so sometimes the questions will be like this, but if you are strong at basics, you can easily solve the question. Don't get confused. Let's move on to the next question. The question is about, in torque slip characteristics of a three-phase parallel induction motor, the maximum torque. Okay, maximum torque. So in any mathematical equation, if you see the torque slip characteristics, this is the torque slip characteristics of induction motor. Okay, so in any mathematical equation, the variable is here, the variable is s. That means torque is in terms of slip. So here variable is s. So for getting maximum torque, dt for getting maximum torque, we need to derive the torque with respect to s and make it to 0. dt by ds is equal to 0. Why we need to derivate with respect to s means, here the variable is s. So we have to derivate the term t with respect to s and make it to 0 to get the maximum torque. So our option will be B. Okay, let's move on to the next question. If per phase rotor resistance and reactance of a so here what we need to understand, they are telling at standstill condition. Don't forget, they are telling whatever the values they given is standstill condition. To obtain the maximum starting torque, the external resistance to be connected. So they are asking about maximum starting torque. The external resistance to be connected in each phase. Okay, first we will understand the question. So they are telling about maximum starting torque. The concept is about maximum starting torque. We know that slip at maximum torque can be given as R2 by X2. They are telling they are adding some external resistance so that it will reach maximum torque at the starting condition itself. We know that at the time of starting, what will happen? S is equal to 1. So therefore 1 equal to, now they inserted the external resistance Re during starting time. It will be like this. Okay, let's see the given data. What is the given data? R2 is given as 0.02 and X2 is given as 0.2. Therefore R2 plus Re is equal to X2. Re is equal to X2 minus R2. X2 is 0.2, R2 is 0.02. So it will come around 0.18 ohms. Therefore the external resistance required to get maximum torque is 0.18 ohms. Option B. Okay. So if you see the question, they given the resistance and reactance at standstill condition. Now the question, what they are telling, to get the maximum starting torque, how much resistance we need to insert in the machine. Okay, for that what we are going to do, we need to derive the relation between the maximum slip at the maximum torque. Okay, we know that at maximum torque the slip is going to be R2 by X2. From there we calculated the external resistance. Is it clear? Let's move on to the next question. The input and efficiency of 3-phase 50 Hz 1350 rpm 4-pole induction motor is 9 kW and 80% respectively. Calculate its stator losses. For this we need to understand the power flow diagram. Power flow diagram. So we are giving the electrical power input to the stator. From stator it is transferred to the rotor. From rotor it is developing the mechanical power. This is mechanical power. In between, what are the different losses occurred? In stator copper losses will be there. This will be the stator losses. After stator losses, whatever the power is going to rotor, that is called rotor input power. Rotor input power is nothing but Pi minus PSL. So in rotor also some mechanical losses will occur. Okay, mechanical losses will occur. So whatever the gross mechanical power developed will be the PG. Net will be the Pn is equal to Pg minus Pm. This is the power flow in induction machine. So if you see the given data, what and all the parameters, they given the efficiency and they given the electrical input power, and they given speed and pole something they given. But what they are asking stator losses. Stator losses is nothing but stator copper losses. There is no information about the direct relation between the stator copper losses and given data. So we need to come from the backward. That means like this. So since they given the efficiency is nothing but net mechanical power developed divided by electrical input Pi. Net Pn can be written as efficiency is 0.8, electrical input power is 9 kilowatt. Okay, what will happen? It will come around 7.2 kilowatt. Let's assume they didn't mention about any mechanical losses in the question. So let's assume mechanical losses are neglected. Then Pn will nearly about equal to the gross mechanical power developed. So what I did, mechanical losses neglected. If they mentioned anything in the question, we need to consider. Since they didn't talk about mechanical losses, so we neglected that mechanical losses. We make it at Pg is equal to 7.2 kilowatt. Okay, so what we need now, in order to calculate the stator copper losses, we need rotor input power. So we know the relation rotor input power to rotor copper losses to gross mechanical power is 1:s is to 1 minus s. Now we need to calculate the rotor input power. And therefore rotor input power to gross mechanical power will be 1 by 1 minus s. Okay, it can be written as rotor input power equal to 1 by 1 minus s into Pg. Let's take it as equation 1. Okay, so for calculating this we need slip. We need to calculate the slip. From the given data, if you see F is 50 Hz, rotor speed Nr is 1350, and poles, number of poles are 4. 4 only given, no? Yes, 4 only given. So now Ns is equal to 120 F by P. 120 into frequency is 50 Hz, number of poles are 4, it will come around 1500 RPM. Okay, so therefore slip will be Ns minus Nr by Ns. How much it will come? 1500 minus 1350 divided by 1500. It will be 150 divided by 1500. It will be 0.1. Okay, 0.1. Therefore, from equation 1, rotor input power can be written as 1 by 1 minus 0.1 into 7.2. It will come around 1 by 0.9 into 7.2. it will be it will be 8. Okay, rotor input power will be 8 kilowatt. Okay, rotor input power will be 8 kilowatt. From this power flow diagram, what you understood, now we are having the rotor input power, we are having the electrical input power. So if you subtract this rotor input power from the input power, then you can get the this one, stator copper losses. Okay, how much it will come? Therefore electrical input power can be written as rotor input power plus rotor copper losses. Therefore stator copper losses can be written as Pi minus Pri. Pi is 10 kilowatt, they given, it will be 8. Okay, so it will come around 2 kilowatt. So the nearby option is B. You have to, nearby option is B. Oh sorry, the given rotor input is 9, no, so option will be sorry, the given input power is 9, so we got 8, it will be 1 kilowatt. Therefore stator copper losses will be 1 kilowatt. So our option will be C. Option will be C. Is it clear? Okay, the calculation may be lengthy, but the question is very simple. Okay, calculation may be lengthy, the question is simple. That means you just understand the power flow, how the power flow is happening from electrical power to mechanical power. If you have a clear idea about that, then you can solve the question very easily. In between you taken one relation. This relation is very important. I already told some relations we need to be remembered to solve the question in a quick manner. Okay, some relations we need to be remembered to solve the questions in a quick manner. So with this relation and some basic power flow information, you solve the question and you got the answer. Okay, let's move on to the next question. A double cage induction motor has better starting and running characteristics because two of the following conditions are satisfied. What they are telling? Better starting and better running. Okay, so in any induction motor we already discussed the starting torque is directly proportional to the rotor resistance. Okay, rotor resistance. Okay, so that double cage induction motor is nothing but a induction motor only, but it is in rotor circuit is having two cages. Okay, inner cage and outer cage. The rotor circuit will be like this. This will be inner cage, this will be outer cage. In order to achieve the better starting and running conditions, what they are doing, the outer cage is going to be having low reactance and high resistance, whereas the inner cage is going to having high reactance and low resistance. Okay, at the time of design they are doing like this. Now what is going to happen at the time of starting? If you analyze the things at the time of starting, what will happen? The frequency will be high. Okay, frequency will be high. That means rotor frequency will be S into F. But at the time of starting S equal to 1. Therefore, FR is equal to F. Okay, at the time of starting, okay, frequency will be high. Frequency will be high. So, the reactance offered by the outer circuit will be less, whereas inner circuit will be high due to skin effect. At the time of starting, due to skin effect, inner case having high reactance. In a power systems, you might have studied that the what is the mean by skin effect. So inner core is going to be having high reactance compared to the outer one. So, and as we designed our outer case has high resistance, so at the time of starting, the rotor resistance will be high. So, as we already discussed, starting torque will be high, as it is depends on the rotor resistance. Okay, understood? Under running condition, what will happen? The both reactances of inner case and outer case both will be same. So it will improve the running performance also. So let's see the options. The inner case having high resistance and reactance. No, it is not correct. Inner case having low resistance and high reactance. Yes, it is true. Outer case having high resistance and low reactance. It is true. This is wrong. So our correct options are 2 and 3. Okay, 2 and 3. Just remember in this question what we need to remember is basic concept of designing of the double cage induction motor. What we need at the time of running, we need high resistance. That's why in a power system you might have already studied that. So the current will flow in the only surface of the conductor. Inside, high reactance will be formed due to skin effect. Same concept will be applicable here also. At the time of starting, inner case having the high resistance. That means high resistance and not high resistance. High reactance is going to be provided. Because of that, the outer only will come into the picture. The outer case is going to having high rotor resistance. Since it is having high rotor resistance, the starting torque is going to be high. Okay. So under running condition, if you consider the full load torque, both resistance and reactance will be less as frequency is reduced. Reactance in the inner case is going to be reduced. Okay. Thereby we are going to achieving the better running condition also. Is it clear? Let's move on to the next question. The question is given about a three-phase 6-pole induction motor is run with a rated voltage V and rated frequency 50 Hz. The maximum torque obtained is Tm1. If the motor is supplied with the same voltage, okay, but a frequency of 60 Hz, the maximum torque would be approximately, okay, maximum question. By reading the question, we understood that it is a V by F control. It is a V by F speed control. The question is related to V by F speed control methods. Okay. V by F speed control method. And what they are telling, when you apply the rated condition, the maximum torque we got is Tm1. Okay. The second thing is, if the motor is supplied with the same voltage, that means V is constant, but the frequency is reduced to 60 Hz. Frequency F2 is 60 Hz. Sorry, increased to 60 Hz. Then what about the maximum torque? They are asking. Okay, let's see. So we know the maximum torque equation 180 by 2 pi ns into E2 square by 2x2. We already derived that ns is directly proportional to frequency, x2 is also directly proportional to frequency, and E2 is, they are telling is constant. Okay. Therefore, maximum torque is inversely proportional to the F square. Since Ns is directly proportional to F, Xt is directly proportional to F. Therefore, Tm2 divided by Tm1 can be written as F2 by F1 whole square. F2 is given as 60 Hz, F1 is given as 50 Hz whole square. Sorry, this will be reverse, no? This will be reverse. Sorry. It will be F1 by F2 will come. F1 will be 50, F2 will be 60. How much it will come? It will be 5 tens, 5 twelves. It will come around 5 by 6. 5 by 6 whole square. How much it will come? By solving this, you may get around Tm2 is equal to 0.7 into Tm1. Okay. So our option will be A. Our option will be A. Is it clear? The question is very simple. Okay. So the first understand the question. The question is about V by F speed control. Okay. In this only frequency is variable, voltage making it as a constant. Is it clear? Okay. Next, they are asking relation about the maximum torque to frequency. Let's note down the maximum torque equation. Maximum torque is given as 180 by 2 pi ns into E2 square by 2x2. From this, we can derive that Tm is inversely proportional to the 1 by f square. Okay. Thereby, we solve the question and got the answer. Okay, let's move on to the next question. Okay. The question is given as a 6-pole 3-phase 50 Hz induction motor has a maximum torque of 10 Newton meter at 875 rpm. Okay, the torque at 5% slip is what they are telling. Actually, the question is not visible to us. Six poles given, frequency is 50 Hz. Okay. So they are telling maximum torque of 10 Newton meter at 875 rpm. Okay, we know that maximum torque at 875 rpm is 10 Newton meter. This is the given data. What they are asking, torque at 5% slip. Okay, torque at 5% slip we need to calculate. Let's note down the equations. Full load torque equation can be written as 180 by 2 pi ns into S E2 square R2 divided by R2 square S into X2 square. Let note down the maximum torque. 180 by 2 pi ns into E2 square divided by 2x2. If you make the cancellations here, it will come full load torque to maximum torque can be given as SR2 by R2 plus SX2 square divided by, sorry, it will go at top, it will be 2x2. That equal to, it can be written as 2x2 R2s divided by x2 square. If you take out, it will come R2 by x2 square plus s square. Okay, after cancel out, it will come 2 into R2s, sorry, 2 into, we can write it as 1 x2 will be cancelled out here. We can write it as 2 into r2 by x2 into s divided by r2 by x2 whole square plus s square. Therefore, full load torque to maximum torque will be this one, equation 1. Let it take it as equation 1. Okay, we know that at maximum torque slip will be r2 by x2. Therefore, full load torque to maximum torque ratio can be given as 2 into SM and SFL. SFL is the full load slip, okay, and SM square plus SFL square. Okay, no need to make all these derivations. If you remember the relation directly, you can substitute. Okay, I am just deriving for your understanding purpose. Okay. SFL they given in our question. If you see SFL they given as 5%, that means 0.05. We need to calculate slip. They already given the NR at maximum torque. Okay, therefore first we need to find out synchronous speed. What is the synchronous speed? Poles they given as 6 poles, 50 Hz. 6 poles and 50 Hz. Okay, 120 into F by P. 120 into F is 50, poles are 6. It will be 1000 RPM. NS is 1000 RPM. So NR we given in the question they given NR as how much? 875. NR is given as 875. Therefore, maximum slip will be 1000 minus 875 divided by 1000. Okay, how much it will come? It will come around 125 divided by 1000. Okay, it will be 0.125. Okay, 0.125. Therefore, TFL can be given as 2 into 0.125 into SFL will be, SFL is 0.05 divided by 0.125 whole square plus 0.05 whole square. How much it will come? Please do the calculation. How much it will come? Let's do the calculation. Sometimes this will be lengthy. With some approximate calculations we need to go. Okay, it will come around 6.9. okay, 6.9 Newton meter. Is it clear? So our option will be D. Option will be D. So the question is simple only, but little lengthy calculations are there. So don't do any mistakes while doing calculations. Okay, you know the concept and you know how to solve the question also. But if you are doing simple mistakes in a calculation, we are going to get the wrong answer. The surprise thing is many of the competitive exams at least 2 options will be matching options they will give. That means to mislead the students, the examiner will be doing whatever the mistakes are doing during calculations, they will do that mistakes and keep it in the options also. So be careful. Even though you know the concept, you know the solution also, but sometimes the mistake is going to happen. To avoid that, you have to practice. You have to practice as many as hand calculations. Why? Because calculator they won't allow in examinations, especially our state exams. In gate exam they will allow. Okay, many of the competitive exams they won't allow the calculator. Okay, so in order to confident about your calculation, you have to be practice. You have to practice the hand calculation as much as possible. Practice the hand calculation. Okay, by this we are going to wind up the today's session. If you have any doubts, you can post over the chat box. I will explain again. Otherwise, we will wind up. Hope my explanation is understandable to the all students. Okay, so if you want to give any suggestions, you can post over the comment box. That will be useful. Okay, that is useful to improve the sessions. Okay, please share and like the channel, so that it will be little encouragement to us to do more sessions, and share the link with your friends also, so that they will also get benefited. Okay, thank you so much.